Welcome to Numbers Simplified. In this channel, we simplify and solve numerical problems. Today, we'll be solving problems of polynomials from the previous tasks on synthetic division, long division, factor, and remainder theorem. So this session specifically will look at the tasks that were assigned in the previous polynomial sessions. For a full description of the topics, check our Numbers Simplified channel where we have all of these sessions. Subscribe to keep up to date with the new sessions and the material. Now, the first task was on the synthetic division. Now that, using the synthetic approach, we got this value 4x squared minus 34x plus 22. But bear in mind, this is not the final solution. Why? Because the coefficient of x in the divisor was not equal to 1. So we also have to bear that in mind and also consider it. We are going to divide the answer that we obtained by that, which is a 2. In this case, we will have 2x squared minus 17x plus 22 as our final answer. Task 2. Still on the synthetic division task. This time around, we have the divisor that is non-linear. We know that we cannot use that on the synthetic division. However, we can factorize that to have x plus 1 times x minus 1. Then we divide using the synthetic division 2 times. Initially, I chose to use lambda of 1, so meaning that I used the x minus 1 divisor part. I obtained the answer, which is a quadratic x squared plus 3x plus 2. Now, there are two approaches here. I could use the factorization method, which is easy, or use the synthetic division once again. So using the factorization method, I would have x plus 1 times x plus 2. But because I know that the x plus 1 was part of the divisor, so meaning that the one that comes out as our final quotient is x plus 2. Method 2, using the synthetic division again. So if we continue with our synthetic division, once again, we are going to get x plus 2, which we obtained previously. Now, how about I tell you there is another method that could be useful here? Of course, the long division method. Now, recall from the long division task, we had the same question that was in the synthetic division video part 2. So with this one, we can consider it to be the alternative. So this question had 3 ways of being solved. So now let's look at the long division. In the long division here, we would get the same answer, x plus 2. Now, the choice of using the method belongs to you. You would know which one would work best for you. But in this case, I would go with the long division, though I like the synthetic more. Now, moving on to the pros and cons of the synthetic and long division task. So this was a video. If you want to check it out, make sure you do so. You might get some lot of insight. Now, this was the task. We had the polynomial f of x. We had the divisor. So we'll start with the part A. So with the part A here, we are asked to find the remainder. Of course, we can use the synthetic method, the long division, but why should we go all that far when we can use the remainder theorem? So in this case, we use the remainder theorem. Recall from how we use the remainder theorem. If you don't know or if you've forgotten, check out our remainder and factor theorem video. We explain this. So now we get our lambda which is 2, and we substitute it into f of x. Now, okay, so we have f of lambda, so that we get a minus or not minus, but 33 at the end. The remainder is 33. So that is our answer. Going to part B, the long division. So you know that with the long division, we consider the leading terms of the divisor. That is what we would use in dividing the dividend terms individually. So we'd go about it and get the answer as 2x plus 13. That is our quotient, and our remainder is 41x minus 15. So make sure to check out our long division video for more details. Now, moving on to the factor and remainder theorem task. Now, this one was an amazing one because it had 3 divisors. One which was a factor, and 2 others which were not factors but just dividers. So going about this, we would have 3 lambdas. One lambda, or lambda 1, would be from 2x plus 1, lambda 2 from x minus 4, lambda 3 from x minus 2. We set this to 0 and solve. So we get lambda 1, which is minus half, lambda 2, which is 4, lambda 3, which is 2. We substitute these values individually into the p of x, so that we have p of lambda 1 equal to 0 because this was a factor. We evaluate, we group the like terms, we get the first equation, which is a plus 4b is equal to 12. We do the same thing for lambda 2 and lambda 3 using the relationship that was specified in the question. We evaluate, grouping the like terms, and then we get to the final equation. In our final equation, we get 4a minus 2b is equals to minus 150. That is our equation 2. So we've got 2 equations that we have to solve. So it's easy to see that subtracting equation 2 from 4 times equation 1 would be easier. Now that would help us eliminate the a. Why? Because we are saying 4 times a plus 4a, or rather minus 4a plus 4a, that would give us a 0. Then 4b times 4 minus 2b would get 18b. 4 times 12 minus 150, we get 198. b is equals to 11. Substituting for b into 1, we get a is equals to minus 32. Now, it was as easy as that. So the polynomial we were looking for is that. If you have made it this far, congratulations. Please write down the following in the comment section: your experience in the sessions, your preferred numerical future topics, your questions or concerns, your suggestions. Remember, your feedback is always welcome here. Thank you so much for watching Numbers Simplified. God loves you.